What's up, guys? In this video, we're going to be carrying on with lesson 2 of crypto zombies. So if you want to follow along, head over to cryptozombies.io. I'll leave a link in the description. If you're following along with the playlist, I already have lesson 1 up and we went through all of that. I recommend going through that first. It'll give you a lot of context, and we're going to be using a lot of the same code throughout this as well. All right, so let's get started. In lesson 1, we created a function that takes a name, uses it to generate a random zombie, and adds that zombie to our app's zombie database. So basically, we just take a name, and whatever name you give it, it'll generate some random zombie for that name. So in lesson 2, what we're going to do is we're going to make our app more game-like. We're going to make it multiplayer, and we'll also be adding a more fun way to create zombies instead of just generating them randomly. How will we do it? By having our zombies feed on other life forms, right? So you see these humans down here. That will be, I guess, what our zombie here will be feeding on. When a zombie feeds, it infects the host with a virus. The virus turns the host into a new zombie that joins your army. The new zombie's DNA will be calculated from the previous zombie's DNA. So if you remember from the last lessons, the zombie had a DNA associated with like the object. And the host's DNA. So the host will be, one of these guys, right? And so, what do our zombies like to feed on most? To find that out, you'll have to complete this entire thing. It won't just be people. You'll see what it is if you follow along with the video. All right, so there's a simple demo of feeding to the right. Click on a human and see what happens when your zombie feeds. So if we click on one of these guys, all right, and we get a zombie, right? So we see that we have no name's DNA, which is, I guess, the zombie. It's just initial name is no name. And then human's DNA, which may even be named human or just something random, I don't know. And so this is your new mutant zombie. So we go back and try another combination. I don't really know what the pluses here are for, like +5 or whatever, but they're there. So you can click on another one. You can see, okay, here's another zombie generated from the initial zombie's DNA and then this particular human's DNA. All right. So let's see, you can see that the new zombie's DNA is determined by original zombie's DNA as well as the host DNA, so that's how it's like unique. When you're ready, click next chapter, and we will do that now. All right. So what we're going to be going over in this chapter is mappings and addresses. So what is a mapping, right? Before I really, read the rest of this. A mapping, if you know Python, it's like a dictionary, right? So you can think of it just like as a map or something like that. If you know in other programming languages, you probably have come across the concept of a map, right? Or like a key value pair. And so that's basically what a mapping is. It's just like a dictionary from Python or just a map from Java or something like that. And then we have addresses. So an address is something that is unique to basically everybody that interacts with the Ethereum blockchain. So basically everybody has a unique address, right? It's like your bank account. You can kind of think of it that way. So let's go ahead with this. Let's make our game multiplayer by giving the zombies in our database an owner. To do this, we'll need 2 new data types, a mapping and an address. All right, so addresses. The Ethereum blockchain is made up of accounts, let's see, which you can think of like bank accounts. An account has the balance of Ether, and I think I said that earlier, which is the currency on the Ethereum blockchain. And you can send and receive Ether payments to other accounts, just like how your bank account can wire transfer money to other bank accounts. So just think of like when you're sending Ether from one address to another, it's just like sending money from one bank or just one bank to another, right? Each account has an address, which you can think of like a bank account number. Yeah, so I think I went over that. And this is like an idea of what it is, right? So this is like a hexadecimal string representing your account number, all right? I guess this one, like it belongs to the Crypto Zombies team, so if you want to send them Ether, it's like a hot address, right? So you could actually just send the Crypto Zombies team actual Ether, which, is worth actual money, just by sending some Ethereum to this address right here. All right. So all you need to understand for this lesson is that an address is owned by a specific user or a smart contract. Smart contracts, all contracts, by the way, have an address associated with them. So Zombie Factory has a unique address associated with it, and so do just like people on the blockchain, right? All right, so we can use it as a unique ID for ownership of our zombies. When a user creates new zombies by interacting with the app, we'll set the ownership of those zombies to the Ethereum address that called the function, right? So basically, you're going to own all of your zombies. They'll be unique to you. All right, in lesson 1, we looked at structs. So if you remember structs, it's kind of just like this thing right here. It's like giving us our own like type, or just like kind of more complex type that can have different data types associated with it. And then we also went over arrays. So you can see this is an array of type zombie, right? Which is our struct here, right? Okay, so what are we looking at now? So mappings, yeah. So mappings are another way of storing organized data in Solidity, right? So like this is organizing it in an array. This is organizing, like a struct is like giving it like fields or attributes, right? To like a new type or something like that, right? And what we have now is we have mappings. And mappings are basically, like I said earlier, just key value pairs. So you have a key and it unlocks a value. It's like a dictionary in Python. All right, so for a financial app storing an unsigned integer that holds the user's account balance, you might have something like, okay, you give it an address. So remember, you have an address on the Ethereum blockchain, like if you've created one before, or you could just think your bank account, right? And so say you put your bank account number in, and it gives you back an integer that says, okay, here's the balance on that account. This is what they have, right? I don't know if that would be an integer or a float, but yeah, basically, you know, whatever. Or you could use it to store lookup usernames based on a user ID. So like imagine you have some user ID that is in the form of numbers, you know, just whatever you can think of, like maybe your social security number. And then under your social security number, you have like a string, which is like your name, right? So someone could go into this thing and say, okay, well, it's this big mapping. So there's tons of social security numbers in here. We put in yours and then your name comes out. I probably wouldn't put my social security number on a blockchain though. A mapping is essentially a key value store for storing and looking up data in the first example. The key is an address and the value is an unsigned integer. And in the second example, the key is an unsigned integer and the value a string. Yeah. So we went over that. Let's put it to the test. So to store zombie ownership, we're going to use two mappings. One that keeps track of the address that owns a zombie and another that keeps track of how many zombies an owner has. So basically, we're going to say like, okay, one thing keeps track of the address that owns a particular zombie, right? So we're going to have zombie to owner. So if you just see some random zombie, you can know who the owner is through this mapping. So what you'll do is you'll put in a zombie and you'll get back the address, like the address, like this kind of address here, to know who owns it. Because remember, addresses are unique to users. And then the key will be, let's see. Yeah, the key will be a uint, which is basically like, you know, the zombie, which gives back the address, yeah. And then we're going to do another one, which is owner zombie count. So we're just going to put in an address, again, which is unique to the user. And we'll get to know how many zombies that user has. So how big is his horde or army of zombies. So let's get started with this. We'll do a mapping. And we'll do, let's see, what's the first one? It's going to be a uint to an address. Right? And we want this one also to be public. And we're going to call this what? Zombie to owner. Okay, and then we'll do another mapping. Whoops. And this one will be an address. Whoops. To a uint. And this one will be private, so we won't put anything. At least, I think it'll be private, yeah. And then we'll do owner zombie count. All right. Let's try that. All right, so next chapter. Now we're going to go over something called message.sender. Okay, so let's talk about that. I guess I'll let them explain it. So now now that we have our mappings to keep track of who owns a zombie, remember the address is the unique thing that owns the zombie, right? We'll want to update the create zombie method to use them, right? In order to do this, we need to use something called message.sender or msg.sender. So message.sender, in Solidity, there's a certain global variables that are used, global variables that are available to all functions. One of these is message.sender. So basically message.sender is a global variable. You can use it anywhere. It's always available. You can use it in all of your methods, whatever. And what it does is it refers to the address of the person, or remember, contracts have addresses as well. So remember, like a smart contract could just reach out to another smart contract and call it, right? It doesn't need to be you from your address calling a method. It could be some, and we'll see this later, it could be some just smart contract calling another smart contract. And if it does that, message.sender will be the address of the smart contract. If you call it, it will be the address of your particular address that you created based on your private key, right? Let's see. So in Solidity, a function execution always needs to start with an external caller, right? So like there will need to be some sort of external caller. So like this contract needs to call something externally, or you need to call some contract externally. There needs to be something that calls it, right? And there's basically always going to be a message.sender because like you're calling it, something's calling it. We need to know who's calling it, and we're going to do something based on that user. All right, so this is an example here. So what do we have? We have something for favorite number, and you can already see, like, you know, ignore these functions, right? Just think like, all right, we have an address that maps to an unsigned integer, which is somebody's favorite number. So don't even think about or even look at these functions yet because it's a lot of, you know, text. But you could just think about like what this puts on the blockchain. So an address is you specifically, so probably a contract wouldn't be calling this, right? And then the uint is just your favorite number. So you could just imagine right now you're just mapping your particular address and putting your favorite number on the blockchain. And that's what it does here. It says set my number, which just puts it onto the blockchain. And we have a mapping here. So this is how you interact with a mapping. So we have favorite number, right, which is this mapping here. What does it take in here? It takes in message.sender. That's the key. So it's of type address, right? So this is message.sender is of type address, right? Because it's your unique address. Remember, it's global for whoever called the contract. And that is going to be equal to my number, right? Which is a uint, which comes in here. And we know that it accepts a uint as the value. So the key is message.sender for address and your favorite number for the unsigned integer. All right, and then what is my number just goes and gets it. So how you index, or not really index, but how you you could say unlock a value, right, is you pass it a particular key. Now we know the key will be an address, so message.sender is you know, an instantiation of an address, right? And that will just return your favorite number that you set on here. All right, so we won't talk about that because I think I just went over it. It gives you security on the Ethereum blockchain, right? So it always knows it's you, and it's, you know, the only way someone's going to be able to pretend that they're you is if they have your private key. All right, so let's put it to the test. Let's update our create zombie method from lesson 1 to assign ownership of the zombie to whoever called the function. First, after we get back to the zombie's ID, let's update our zombie to owner mapping to store message.sender under that ID. All right, so we're going to do that here. And the first thing we want to do is after we get back the zombie's ID, let's update our zombie to owner mapping to store that thing under the ID. So what we're going to do is zombie to own, I guess that doesn't complete for me. Zombie to owner, right? And it will be under the ID. So we got this ID here, I think is the one we want to use. So will be for ID. And then we want to set that to, because remember, zombie to owner, the key right here is an unsigned integer. And then what goes in for a value, it's an address. Well, it might as well just be message.sender, right? And so now we have like the ID, which is the key, and we can say like, okay, we want to know who owns this zombie. The zombie has an ID on the blockchain. Now let's find out who owns it, like what account is associated with this zombie. All right, so the next thing we're going to do is increase owner zombie count for this message.sender. So this will be simple. What we'll do is just owner zombie count. Remember, this is going to be associated with an address, so you can see the address here. So the address, obviously, again, will be message.sender. And we'll just do ++ because that is supported. Basically, it just increments the count that's there, right? All right, so next chapter. So now we're going to be going over require. Now require, what it's going to do is it's going to require something be true before we kind of go ahead with a function, right? So in lesson 1, we made it so users can create new zombies by calling the create random zombie. and entering a name. However, if users could keep calling this function to create, they could just create unlimited zombies, right? Like there would be no need to like eat new zombies or do whatever. So we want to just start out with every user, I guess, just gets one zombie. That's kind of the idea. So how do we make this function so it can only be called once per player, right? Now, how we're going to achieve this is using the require, I don't know if it's kind of like a built-in method or something like that. But so require makes it so that a function will throw an error and stop executing the contract. And you could think in the future how this could be trouble. Like if you get so many times through a contract and you start putting things onto the contract, that costs ether to like actually write things to a contract. So if like eventually later down the line you reach a require statement, and this is I guess a little bit more advanced than what this is going over, but later on if you reach a require statement like down the line, and your contract just throws an error and breaks like halfway through or something like that for whatever reason, someone will have spent some ether before they got there, and then the contract didn't work. I don't know if you guys have ever used Uniswap or something like that before, but it's happened to me and it kind of sucks. I don't know if it's for that reason, just like if there's not liquidity or something, but whatever. So for this we use require, right? So it'll stop executing if this thing is not true. So you see we have some, just logical operator here, right? Like we could have like less than, but what we have here is double equals. So what we're going to do, like this one for instance, name comes in, and what we're going to do is we're going to check if name is equal to Vitalik. If it is equal to Vitalik, we return hi. If it's not equal to Vitalik, we just throw an error and we never get to this return statement. So this is kind of like a validate check before we do anything. All right, so let's put it to the test. In our zombie game, we don't want the user to be able to create unlimited zombies, so because they could just keep calling random zombie. It would make the game, they could do whatever they want. All right, so let's use require. So we're going to put a require statement, and usually you just want to look for the comment here. All right, so we're going to do require. All right, and let's see. So put a requirement statement at the beginning of create random zombie. The function should make sure that owner zombie count message is equal to 0 and throw an error otherwise. Okay, so we're just going to take this here and copy it and paste it there. And then we're just going to give that there and say, all right, we're going to require that the owner zombie count, like the number of zombies that he has, and we know that the owner here is the person calling the smart contract, and this is their account. And we're going to make sure that that is equal to 0. So he doesn't have any zombies yet before we do this. All right. So next chapter, and we're going to be going over inheritance. Now, inheritance is kind of like in object-oriented programming, or an object-oriented programming like concept, right? So if you've done object-oriented programming before, then you probably already kind of get what inheritance is. But if you haven't done it before, it's not that complicated. You'll kind of see where we're going with this. So let's see. So one reason you might want to break a contract up, right? So you can already see like here, I have to scroll down to kind of see some of this stuff. If I keep adding a bunch of nonsense to this, like you'll see people who write code and there's like 1,000 lines under maybe a particular contract, or maybe a particular class if you're just thinking like whatever, just normal coding or just whatever, right? And they just pile all their functionality into one giant file, and that's not usually like a good thing. Like it leads to very, poorly structured code. So what we're going to do is we're going to use this to kind of break things up. Now we're going to start the other class under here, but you'll see in the next section they're going to move it to a new file. But anyway, so let's talk about what inheritance is. So basically, you can think of a contract like a class, right? And so our contract is Doge. And so this Doge contract has a function called catchphrase. And you don't have to pass it anything, and it just returns you something back. And this is public, so you can call it from here. And so what it returns is so wow crypto Doge, right? Now, if you say baby Doge is Doge, then what you're doing is you're giving baby Doge access to this function called catchphrase, whereas baby Doge can also run this function called another catchphrase. So baby Doge can do catchphrase and another catchphrase, all right? But regular Doge can only do catchphrase, right? It doesn't know that this one exists, but baby Doge knows that both exist. Now, baby Doge is essentially like, you know, like it's kind of like, you know, it can do everything Doge can do, and also now this new function, right? So when we have something like that, or we have this we say that it inherits from the other contract, right? All right, so let's put that to the test. So what we're gonna do is we're gonna create a new contract called zombie feeding. All right, that's what it says here. So make a contract called zombie feeding below zombie factory. This contract should inherit from zombie factory. So that's all we need to do. So actually, we're gonna put a contract keyword here. Contract, and then we're gonna say is zombie, and we'll just do factory. All right, so we'll check that, and we'll move on to the next chapter. Now you'll see what just happened here is we added our pragma to back here. So what did I just type back there? I literally just typed this, and that was all. And I put it under our other contract. So we could keep them in the same file, but it's, you know, it's not really clean to do something like that. So this one started to get a little bit, you know, a little bit long, started to have a little bit too much in it. So what we decided is to break this out into another file. So we're gonna put all of this new logic in this new file, so this one doesn't get too cluttered. All right. So we had to do our pragma again, just, you know, just the same as you would do with any, right? And now we just have, you know, this contract here called zombie feeding, and it inherits from zombie factory. Now the problem is, in this new file, it doesn't know that zombie factory exists yet. So what we're gonna have to do is we're gonna have to import that other contract. And they're just going over that they did that, explaining that. And so what we need to do is import it, right? So like we have zombie factory here, but how could this file know that that exists? And the way that it does that is with the import statement. All right, so we're just going to do import. We'll put it's like a string. Dot slash dot just kind of means here, like in this directory or in this space, and then slash, and then we'll point to our zombie, and I think it's just factory dot soul, and you actually have to put the extension on there as well. All right. And I think that's all we really need to do for this one. I will also probably need to put a semicolon there. All right, and we're done with that chapter. All right, now we're going to go over what is storage versus what is memory. So in Solidity, there are two locations that you can store variables, storage and memory, right? Now you can think of storage kind of like if you understand like how your computer's built, or you understand what a computer is kind of made of. You have two different ways to store things, right? So like this web browser that I'm in right now is stored in memory. And when I turn off my computer, it might, well, you could just think like, okay, there's no caching or whatever. Like it won't remember what page I'm on or what I'm doing or whatever, right? Like my browser won't turn back on. But there's also things like storage, which is like your documents and things like that. So stuff that's written to your SSD or hard disk drive, that's storage. Memory is like all the programs that you have open right now. Like I'm running OBS to record this. I'm running this web browser and this program inside the web browser. This is all in memory. And storage has maybe like all of my documents, downloads. If you have music or something like that, that's in storage. So in this case, storage refers to variables stored permanently on the blockchain. So things that are actually just on this distributed chain, like forever, decentralized. That's what we're referring to when we're talking about storage. Now, memory variables are temporary, and after we're done calling some contract and it's done doing something, they go away. So that thing is not recorded, eternally on the blockchain. And they said hard disk versus RAM, which is kind of like what I said earlier. All right, so most of the time you don't need to use these keywords because Solidity handles them by default. Which, if you don't know what the defaults are, I guess that could get pretty confusing. But we'll say state variables are variables declared outside of functions. So we can think of this as like a state variable, right? They're by default storage. So you can think of anything that's out here as a storage variable. So if I go over here and I show you, like this is a storage value, this is a storage value, and our array here is a storage value, and our mappings are storage values, right? Obviously, this string here is memory, and I'm pretty sure these guys are memory by default as well. So let's see. While variables declared inside of functions are memory. So if we declared like this guy here, this ID, this is also a is declared in memory. All right. So, however, there are times where you need to use these keywords, namely when dealing with structs and arrays within functions. So if we're using a struct or an array inside of a function, we may want to move that into storage. So let's take a look at this example here. So what we have is we have a contract called Sandwich Factory. And we have this sandwich type here, and then we have an array of sandwiches, right? So we can have something called eat sandwich. This is like our function, and it, I guess, takes in an index. So you're eating some sandwich at some index inside this array, right? So you could have, I don't know, like, you know, oh, this is read-only right now, so I can't do anything. But you could think like, you know, 1, 2, 3, 4, 5 sandwiches. You pass in sandwich number 3, and I guess you eat it, right? So sandwich is a storage. So instead, you would declare with the storage keyword. Let's see. So what you would do, right. So what you would do is you would say this. So you have some sandwich at storage number 5, right? And they, you know, they each have like some values associated with them. So this sandwich's name could be like turkey sandwich, and originally it could be, you know, uneaten, right? Now, what you would do is you would say, okay, instead of doing this in memory, we want to do this on storage. We want to write this to the blockchain. And what we're going to do is we're going to replace the status from uneaten, which it might be originally, and we're going to replace it with eaten, right? This is one way to do it. And I guess this is another way to do it where you copy from memory and you know, do some things. So you can kind of read over this if you kind of want to, you know, take a deeper dive into that. All right, so let's put this to the test. It's time to give our zombies the ability to feed and multiply. When a zombie feeds on some other life form, its DNA will combine with the other life form's DNA to create a new zombie. And we saw that in the beginning. We had like the original humans, we had a zombie, we kind of meshed them together, and you know, we got a new zombie. All right, so create a method called feed and multiply. So we're gonna go, where are we gonna do that? We're gonna do that here. Okay. Oh, I guess I could type in this one. All right, so we got feed and multiply, right? It'll take 2 parameters, and actually you need the function keyword first. So function, feed, and multiply. All right, and it's going to take 2 parameters, which will be zombie ID, which is an unsigned integer. So we'll have zombie ID. And then we have target DNA. So underscore target DNA, and actually that needs to be an unsigned integer as well. All right, and this method will be public, which means that somebody could call this method. Okay. So the next thing we're going to want to do is we don't want to let somebody else feed our zombies, right? So we know who we are. We are message.sender, right? So to make sure that it's us, we're going to do a require statement to verify that message.sender is equal to the zombie's owner, right? Now, if you remember from our other thing or our other contract here, we know who the owner is. We can look up the owner, right, by the zombie ID. So what do we have here? We have a uint, which gives us back an address, which is a mapping from zombie2 owner, right? So this is how we're going to get it. We're going to require that, let's see. So we're going to want to do require, right, that I think they have a particular way that they want to do this. Switch order, yeah. Expecting message.sender to come first. Okay. So require that message.sender is equal to, and we're going to look this up. So we're going to do zombie2 owner, like that. And we're going to pass in our zombie ID. Okay. That should be right. Now, the next thing we're going to do is, so basically what we're saying here is you can't feed my zombies unless you're me, right? So we're getting the owner of the zombie by its ID, right? I think I moved something around there. But yeah, we're getting this owner by its zombie ID. And we're saying, okay, is that owner me? And if it is, we can feed it. So we're going to need to get this zombie's DNA. So the next thing our function should do is declare a local zombie named myZombie. All right, so what we're going to do is we're going to do type zombie, zombie equals, or no, zombie myZombie is equal to, we're also going to want to make sure that this is storage. So storage, I think it's like that, but we can come up here and check. So it'll be type, then the like kind of modifier here, whether it's storage or memory, and then the name of the variable. All right. And so remember, we're going to be actually adding this thing to the blockchain. Okay, so now we have storage myZombie, which would be a storage pointer. Set this variable to be equal to index zombie ID in our zombies array. In our zombies array. All right. So remember, zombie IDs are literally just like 1, 2, 3, 4, 5, 6, 7. They're just like indexed, right? So we're gonna do zombies, right? And I'll show you where we're getting zombies from, because you don't see zombies here, right? Where we're getting that from is we're getting it from here, this zombies array. Now, if you didn't, make sure that you remember everything from section 1. If you want to remember, like, okay, this is where we're storing all of our zombies. And they're literally just indexed. Every single time that, like a new zombie is just like a new number. Like we have zombie number 1 or 0, 1, 2, 3, 4, 5, 6, 7, off to infinity, right? So let's do this. We're going to get it by its zombie ID, which is going to be a number from 0 to whatever, right? So zombie ID. Okay, so we now have myZombie. And we're going to set this to be, yeah, we already did that. And I think that's all we really needed. I don't know if there's really anything else. 1, 2, 3, 4 lines. It told me to expect 4 lines, and we'll try that. All right, that was right. Okay, so chapter 8, zombie DNA. So let's finish writing the feed and multiply function. That's the one we're working on right here. The formula for calculating a new zombie's DNA is simple. The average between the feeding zombie's DNA and the target's DNA. So you remember, like, I mean, we didn't know how they were calculating the new zombie before, but we have this dumb, simple formula for doing it, right? So we're just going to add the 2 and then divide by 2. That's basically the simplest way to do this, right? So you can see, like, if we added these up, you would have just a ton of 6s. And then if you divided by 2, you would have a ton of 3s. All right, so later, like they said here, you can make it more complicated if you wanted to, but like it's really arbitrary. You can kind of come up with whatever you want, but probably not in this case. But you could if you wanted to, if you were creating something like this. All right, so first we need to make sure that underscore target DNA is not longer than 16 digits. We know we can do that. So if you remember from lesson 1, we're just going to use the modulus operator. So we're going to say that target DNA is equal to target DNA, and we're going to use modulus, and then we're going to do DNA modulus, something like that, right? Now, if we come over here, you can see we have DNA modulus defined here. So I'm not just pulling that number out of nowhere. Okay, and now the next thing we're going to do, so next our function should declare a unsigned integer named new DNA. So if I do uint new DNA and set it equal to the average, so basically the exact same thing that's literally here right now. So the average of the zombie's DNA and target DNA. So myZombie. So how do we get the myZombie's DNA, right? So myzombie.dna is how we're going to do that. And again, we have to go look at our zombie factory.sol over here, and you can see that zombie objects or zombie structs have an attribute called DNA. So we can just, to get that attribute, we can just do dot that attribute. So the same way we could do myzombie.name if we wanted to. All right, so now we have our zombie's DNA. I actually need an equals sign here. And also we're going to put this here. We're going to do this. We're going to do plus and our target DNA. And I'll talk about this in a second just so you're following along with what everything is here. So we have the zombie. This is the zombie that, like, I guess is turning the new zombie. or turning the whatever it is, so it could be a human. This is the DNA of the human. So this is the DNA of the human plus the zombie that's turning it. And this is the formula to get the new DNA of what the target DNA or the human is going to turn into. Okay? All right, so once we have the new DNA, let's call create zombie. So we'll come down here and we'll do create. And it's actually a private guy there, which may be trouble, but we'll talk about that in a second. So zombie, so create zombie. All right. And so what we're going to do is we're going to pass it some values. So the first thing is its name. We're just going to give it no name for now, and then in the future we could change the names later if we wanted to. So what does create zombie, what does it take as parameters? So create zombie takes in a name and some DNA. So we already know what the first thing is going to be. We know that the first thing is going to be no name. And then we know the next thing is going to be DNA. So that will be the new DNA. And we've created a new zombie. Just like that. Now, I'm pretty sure that should be it for this function here. All right, so next chapter. So the code in our previous lesson has a mistake, and I think I just, I briefly made a comment about what that mistake might be. There is this concept of public and private, like access modifiers for particular things, whether they be like fields here, or whether they be functions, right? So you can see this function, create zombie, is totally private. So if it's private, that means that this contract and this contract alone has access to it. Now there's public, and if I made it public, okay, other contracts could access it, but everything could access it at that point, and we don't necessarily want that either. So we don't want it to be private because we actually can't use this method here. So we don't want it to be that private because now I can't call it in a kind of a derivative or like a an inherited contract, right? So a contract that inherits from the zombie factory actually can't call create zombie right now. So how we're going to do that and how we're going to handle that is we're going to add two new access modifiers, and the one we care about is going to be internal. So internal is the same as private, except that it's also accessible to contracts that inherit from this contract. So what we're going to do is, obviously, we're going to change this to internal. So now not everybody can see it out in the wild, I guess, or anyone calling into this contract can't see this method. But other contracts that inherit from this contract can see it. Now, there's also an external access modifier as well, which is similar to public, except that these functions can only be called outside of the contract. So they can't be called by any other contract inside of like your code here. Now, I'm not really 100% sure why that's super useful, but they said they'll talk about why you'd want to use external versus public in a later lesson. All right, so we only really needed to do that. I mean, that's pretty much it. We just needed to change private to internal for this chapter so that we have access to this here. All right, so chapter 10. What do zombies eat? It's time to feed our zombies, and what do they like to eat most? Now, remember, I showed you that they can eat humans, and earlier on they were eating humans, but apparently we have kind of a Crypto Kitties cameo here, and if you don't know what Crypto Kitties is, you can kind of look it up. It's got kind of a funny history. It like really kind of messed up the Ethereum blockchain. I don't know. I didn't pay too much attention to it, but Crypto Kitties is like a thing that exists on the Ethereum blockchain already. It's some smart contract that exists on the Ethereum blockchain. Now, because it exists on the Ethereum blockchain, we have access to it, right? Like we can actually interact with that contract, right? And you can see, because remember when I told you that contracts have addresses, like every single contract that you create has an address? Well, CryptoKitties is no different, right? On the Ethereum blockchain, CryptoKitties has an address, and so do all of these other projects that are built on the Ethereum blockchain. All right, so for our contract to talk to other contracts on the blockchain, so essentially what we're going to be feeding our zombies is these CryptoKitties. Anyway, so for our contract to talk to another contract on the blockchain that we don't personally own, First, we need to define an interface, right? So let's take a look at a simple example here. Say there were a contract on the blockchain that looked like this. So the contract is lucky number. Remember, we're just saying like, okay, the address is some unique person, probably, or a unique account, and we're mapping that to his favorite number, right? Or yeah. And there will be a lot of different people who can map their favorite numbers into this. And basically you're just setting the number and getting the number, right? So now what we're going to do is, obviously I just kind of explained that here. Let's say that we had an external contract, so some other contract that cared about what particular account's lucky numbers were. We would, and because, let's see, the getNum is public, right? We can create an interface for it, right? So let's say we have an external contract that wanted to read the data in this contract using the getNum function. First, we'd have to define an interface to the lucky number contract. So the first thing we're going to do is define some interface, and then we're going to create a method signature here for the function that we're interested in. So we're not necessarily interested in the setNum. We're interested in getting and reading from the blockchain for this contract. So what we're going to do is we're going to do getNum, and we literally just want this. And then you can just put a semicolon afterwards. And that's basically it. So you can see that that's all this is right here. And let's see. So notice this looks like defining a contract. So that is kind of what it looks like. You're kind of defining a contract. But instead of the contract being like functions that you kind of flesh out, you're just giving it a signature. Yeah, that's pretty much all you really need to know. We're going to do the same things for CryptoKitties, and we're going to put it to the test. So we're going to create a kitty interface here. So define an interface called kitty interface. Now you can look at this and you can see like, okay, like this looks a little bit different because Solidity can return like a bunch of junk, right? So like CryptoKitties, when you run the getKitty method, it's going to return you like a bunch of junk here. You may not care about it all, but it does return it all the time. This looks a little bit different than this one because this thing only returns one uint, right? Or one unsigned integer. But this thing returns a bunch of junk. So it looks a little bit different, but it really is no different because I could just have put like a bunch more things in here and it would be like the same thing. All right, so what we're going to do is define an interface called kitty interface. So let's do kitty interface like that. And then what we're going to do is, I mean, really all we need to do is kind of this exact same thing here. So what we'll do is define the kitty interface. Remember, this looks like creating a new contract, so we actually do need the contract here. So contract, and then what we'll do is open this up, and then really all you need to do is take this, right? And then we will paste it in here and put a semicolon, and that's it. And the reason for that is, well, look at this contract. All they had to do was take the function signature and put a semicolon after it. And that's all they had to do to kind of, add that in here. And that's the exact same thing that we did, was okay, here's the one we were interested in. We took the whole function. We didn't care about, anything else, like how it did things or the body of the function. We just cared about taking this and creating a quick, an interface for it. So I'm pretty sure that's it. I guess inside the interface, define the function getKitty. That's this. And the return statement with everything. Yeah, so that's pretty much it. All right, so using the interface. Now that we've defined the interface, we actually want to interact with the interface. And you can see that we have a CK address, the C standing for crypto and the K standing for kitty. So CryptoKitty address. And that's this thing right here. Now, again, remember, all contracts, like your zombie feeding contract has one of these. You don't know what it is, but it has one, right? And anything on the Ethereum blockchain could interact with your zombie feeding contract. Same thing for CryptoKitties, right? So this is the actual, I don't know if it's the actual, I think it is, but the CryptoKitties contract address here. So let's do this. What are we doing here? We're just using the interface. I don't think there's much really to read here. So let's just get on with the test. So I've saved the address of the CryptoKitties contract in the code for you under a variable named CK address. In the next line, create a Kitty interface named Kitty contract. All right. So we're going to do Kitty interface called Kitty contract and initialize it with CK address. All right. So we're just going to say that it equals, I think we have to do Kitty interface and then pass it the contract address. So we're going to pass it CK address. And how I knew to do that was literally if you just look right here, they have number interface, we have Kitty interface, they called it number contract, we called it Kitty contract, they passed their address to number interface, we passed our address to Kitty interface. All right, and that should be it. Chapter 12, handling multiple return values. So you remember that this thing returns a bunch of stuff here. And I think he actually counts it for us. It's 10. So this getKitty function in the first example we've seen returns multiple values. Let's look at how to handle it. So you can see like how, some examples of handling multiple different values, right? So this is multiple assignment here. So you might call, okay, so multiple returns, what it does is it's hard-coded to return 1, 2, 3. It lets you know that it returns 3 things, A, B, and C, which are all uints. And so what you can do is you can say, okay, process multiple returns, and I guess it returns these or something like that. I'm not 100% sure. No, it's declaring these inside of a function. So you first have to say, okay, give me a uint for A, give me a uint for B, give me a uint for C. Something like Python, you wouldn't even have to do that, right? But first you have to give them like containers so that they know what they are. And then multiple returns, which returns 3 things, you can just do A, B, C to get them, right? And then alternatively, if you only cared about one thing, you again would only, allocate some space for the one thing that you cared about. And then instead of putting A and B, you would just, strike them, get rid of them, and then just put commas instead. All right. So what we're going to do is we're going to make a function called feedOnKitty. It will take 2 uint parameters, zombie ID and kitty ID, and should be a public function. So let's start with that. So we got feed on kitty, and it will take uint zombie ID, and it will take a kitty ID, which is also an unsigned integer. So we got kitty ID, I think that's what they want. This will be a public function, so we'll put the public access modifier there, and then we'll just open up our function. The function should first declare a uint named kitty DNA. So just like how you see up here, how we declare the things first, we're going to do that same thing here. So we're going to do kitty DNA. All right. And note in our kitty interface, genes, it's a uint. Yeah, basically all uints are uint 265. So you can see like these are uint 265s. Regular unsigned integers are all by default. Like if you just put uint, it's a uint 265. All right, so the next thing we're going to want to do is 3. So the function should then call the kitty contract.getKitty function with the kitty ID and store genes in the DNA. So that seems a little bit complicated. But really all we're doing is exactly this. We're really doing no different. Well, really we're doing this. So what we're going to do is we're going to open up some parentheses here. We're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. And then for the 10th thing, we actually want to do just like how you see how they have a C here, and then they put the C. What we're going to do is the same thing. We're going to do kitty DNA. And what we're calling kitty DNA, they're calling genes, right? But they're returning genes, it's fine. We're just going to call it this because we have this variable already declared. and it's of the same type. So we're going to say that equals, and we're going to call the function, so it should be inside of the contract. So we'll do kitty contract.get kitty, and we're going to pass that the kitty ID. All right. Finally, the function should call feed and multiply and pass it both the zombie ID and the kitty DNA. All right, so we're going to do feed and multiply here, and then we're going to do, what did it want? It wants the zombie DNA, so we get the, did it want the zombie? No, it wants the zombie ID, so we get that from here. So we're going to do zombie ID. And the other thing that it wanted was what we just worked on doing, right? So this function took in a kitty ID. It used that to get the kitty DNA. All right. Kitty DNA. And so what does this function need? Like, what is feed and multiply? So what are we actually doing here? We're taking the zombie DNA and we're taking, or the zombie ID. We're taking the kitty DNA and we're passing it to feed and multiply. Feed and multiply then takes the zombie ID and the target DNA, which in this case is the kitty DNA. All right, and it looks up, it makes sure that, you own the zombie. Then it says my zombie is the zombie ID, so it goes and gets that zombie ID, whether it be 0, 1, 2, 3, 4, 5, 6, 7, whatever zombie that you happen to create in that array. And then it gets the target DNA and makes sure that the target DNA is only 16 characters long. Then it creates new DNA with the my zombie, because remember we looked that up with the zombie ID that was passed. We get the DNA. We use the target DNA after, making sure, passing it through the modulus here. And then we just create a whole new zombie based on that. So that's what's happening here, kind of step by step. And I think that's all we have to do. I think I got an error here. Let's see what's wrong. So feed on kitty. It's because I never put function in front of it. So we got to remember that. Okay, so chapter 13, this is a bonus chapter, I guess, and then I think we're mostly done. So our function logic is now complete, but let's add in one bonus feature. Let's make it so zombies made from kitties have some unique feature that shows they're cat zombies. So we're going to essentially just make sure that, because you could feed this thing anything, right? Like you could feed it a human like we saw earlier, but if we're going to be getting them and we're going to know that it's like one of the crypto kitties, then we're going to want to do something special with it. To do this, we can add some special kitty code in the zombie's DNA. If you recall from lesson 1, we're currently only using the first 12 digits of our 16-digit DNA to determine the zombie's appearance, right? So we're only using 12 of the digits. Remember that they're 16 digits long, kind of enforced by this. So we have some extra digits to kind of play with. We're going to use the last 2 unused ones. So there's 4 unused ones. But we're going to use the last 2 as special to handle special characteristics. And in this case, we'll say that cat zombies have a 9-9 at the end. I guess their idea is because they have 9 lives or whatever. So in our code, we'll say if a zombie comes from a cat, then set the last 2 digits of the DNA to 99. All right, so if statements, this is just kind of going over if statements. You've probably seen them before. This is saying like, okay, the sandwich, you pass it a string. If that sandwich is a BLT, it's like if you passed BLT, you'll call some other function called eat, right? All right, so put it to the test. Let's implement cat genes in our zombie code. So first, let's change the function definition of feed and multiply so it takes a third argument, a string named species, and remember to store it in memory. All right, so what we'll do is we're going to do string memory, and we need species. Okay, so now we have access to this species variable here, or like it's passed to the function. Next, after we calculate the new zombie's DNA, let's add an if statement. So we're going to add the if statement here under this comment. So an if statement comparing the Ketchak 256 hash of species and the string kitty. If we can't directly pass strings to the Ketchak, instead we will pass the ABI blah 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 as an argument, blah 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 blah. Okay, so what we're going to do is, I think we could basically just grab this, right? And then we'll just get rid of eat there. And we'll go like that. Now, instead of sandwich, what we're going to want is species. So we'll do underscore species. That's probably not how you spell that. And I don't think that is either. So there we go. And we're going to want to make sure that that's equal to kitty. All right. And now if that is the case, then what we're going to do is inside the if statement, they have some logic here for us. So basically what this is going to do, and you can check their explanation down there, but let's just get this in here first. So what this is going to do essentially is it's going to actually add the 99 on the back. So you can see, like, okay, if you have this string or this number here, you do modulus 100 is 55. So new DNA modulus 100, and it just literally, you know, it just puts 00 there. And now after it's done just putting the 00 at the end there, you just add on 99 on the end to mark it as like a cat zombie, I guess. Lastly, we need to change the function called inside feed on kitty, which is, I think, this one here, yeah. When it calls feed and multiply, remember that we have a new thing here for species. So we're going to need to pass that. And when you do feed on kitty, we're just going to hard code kitty inside there. So we'll check that. Let's see, we got something wrong. I added the period in there. All right. So that's pretty much it for this one. And so now we can kind of check out like what we've implemented here and take a look at this JavaScript implementation. Because remember, JavaScript does a lot of like the front end, which is kind of your entry point to a lot of your smart contracts and stuff like that. So that's it. We've completed lesson 2. We can check out the demo to the right to see it in action. But let's talk about some of this stuff first. So once we're ready to deploy this contract to Ethereum, we'll just compile and deploy zombie feeding. Since this contract is our final contract that inherits from Zombie Factory and has access to all the same methods. So we're actually just going to deploy zombie feeding. We don't even need to deploy Zombie Factory because it inherits from it, right? So let's take a look at the example of interacting with our deploy contract using JavaScript. And remember, the library to interact with the Ethereum blockchain or Solidity or whatever is web3.js. All right, so we don't really need to pay attention to a lot of this stuff. We just kind of need to pay attention to the zombie feeding thing here. We're going to say that the zombie ID, because remember, our entry point, what we need is a zombie ID and I guess a kitty ID too, right? Because the zombie ID is saying like whatever the zombie is here, which goes and gets a unique zombie, and then some kitty ID to get you some unique kitty, right? And it's just going to do, I guess, this get API. Yeah, this is just getting you an image for the for whatever cat you're getting by ID. When you click on one, it calls the feed on kitty method. So if I click on one of these cats, we're going to feed on one of the cats and we're going to get a unique zombie out. And then we're going to listen. Remember the new zombie event that we created in the contract before. So like if you remember that emit code, that's important to let our front end know, okay, you need to return something like, or we've clicked on something, so you should update your interface because I clicked on something. All right, so let's give it a try. Select whichever cat we want to feed on. We'll go with this one. All right, and this gives us this guy here. You can notice that I guess he has a tail, and because he has a tail, I guess that's our 99 digits, our added 99 digits of DNA at work. All right. So we could start over. You can see like, okay, we can try another combination. I guess you only get to keep one, so I don't know which one we'll go with here, but I guess we'll go with this guy. All right, and so that's pretty much it for this one. There's really not much else we really have to do here. What we could do, I guess, is share this guy out. In the next video, we'll kind of go over whatever else. We'll keep going through all of the... I'm going to be personally going through all of the crypto zombie stuff because, I don't know, like it's kind of good. I think it's useful for other people who are, you know, kind of just getting interested into this stuff. But it's also just useful for me anyway. So I'm going to probably just finish the entire thing. All right, so I'm just going to go over where you can find me, and I'll continue to make this content so you can check me out on all these places. So if you head over to my website, you can find all my social media links here. If you have questions about some of the stuff I'm doing with crypto zombies or whatever, you can check out the Discord, or really You should check out I think it's here. Yeah, you can check out in the links below this video. You can check out my Matrix server. Also, I would like it if you followed me over on Odyssey. I'd rather everybody follow me over on Odyssey. It's like a blockchain platform. It's, I'd rather people follow me there than YouTube. You can check me out over on GitHub if you want to see like what projects I'm doing or some of the stuff that I work on other than this crypto zombie stuff. Obviously, you can follow me over on Twitter. I don't really post much. I won't spam you every now and then. I do stream over on Twitch and probably YouTube at the same time. If you want to support my work, you can support me over on Patreon. And I think that's pretty much it for this video. You can find everything also in the descriptions for these videos. Also, make sure to like and subscribe, and I'll see you guys in the next one.